I will introduce our first speaker, Dr. Janao Deng. He's from the University of Florida, a plant breeder and professor of environmental horticulture, and he'll speak on caneberry breeding and variety trials in Florida.
Thank you very much, Dr. Nepsi, for the introduction, and also thank Dr. McWorth for her invitation. This is my first time, speaking at this conference, at this, workshop. So my name is Janao Deng. I'm from University of Florida, but not from the main campus. I'm from one of the research and education center called the Gulf Coast Research and Education Center in the Tampa Bay area. I think I need to point this out because this has a lot of, to do with the talks, the data I'm going to present today. So, as the public commercial production of caneberry is a relatively new thing in Florida, unlike in Georgia or in North Carolina, South Carolina. So it's commercial production is a relatively new thing in Florida. And also, caneberry breeding and variety trials, even newer. I started raspberry trials and breeding 2 years ago, Blackberry breeding, about 10 years ago. So I'm still learning, and I'm hope, by sharing what we have, obtained in data collection, and also I can learn from you. So I mentioned I'm from the Tampa Bay area. As you know, Florida expands over like 400 miles from the south Miami area to the north border. And the state covers, like a 4 hardiness zone. So the winter temperatures varies a lot from the south to the north. So this is very important. And okay. So as we talk about Blackberry, probably this is what typically you are thinking. The plants are erect, they have multiple canes and multiple nitrals, and each nitral is loaded with a lot of berries. So that's what you think about the Blackberry. So these are 2 pictures I took at the fruit research station in Clarksville, in Arkansas. So this is a Ponca in 2022. And then I'm going to show you, this is the same variety in Central Florida in spring 2022, in the same year. If I don't tell you it's Ponca, probably you won't be able to recognize that at all. So Ponca becomes very differently in Central Florida. And also other varieties as well. So far, we have tested 25 varieties, including 20 florkin varieties and 5 primkin varieties. So most of them are from University of Arkansas, one from University North Carolina State University, and a number from other places. We see similar phenomenon. So, the plants, they are just very different from the plants grown in other states. So I have summarized the differences into 10 aspects. The first is that the growth habit, they are different. So normally, the new varieties are erect, but in Florida, in Central Florida, the canes are soft, and some of the semi-erect varieties, they even became training in Central Florida. Then second, we have a much longer growing season. So the plants may start to grow in February, early February, or even in late January. Then they continue to grow until November, December. So they have 9, 10, or even 11 months of growing in Central Florida. So consequently, they have little time to rest or going dormant. And then we have very low bud break. Sometimes 1, sometimes 5 or 10, 20. If we can get 30% bud break, that would be great. But sometimes we just got so, little bud break. And then, because of this, the fruiting nitrals are short and have very few flowers. And consequently, plants in Central Florida have a few flowers, have much lower yield. So So that's a big problem in Central Florida. And also in terms of primary production, some varieties, they can produce more primary in Central Florida. But most of the varieties produce fewer or even no primary in Central Florida. And then in some cases, we say, the Floricans, like in Panca, they can survive. They don't die back. So there are a lot of differences in, Blackberry between Central Florida and other places. And the main reason is that we have very low chill hours. So these are data from Mayo, that's in North Florida, then Cetra, that's in Central North Central Florida to the south of Gainesville, and then Baum and Dover, that's our area. You see, historically, we have 100 to 200 chill hours, but in recent years, sometimes we have less than 100 chill hours. Okay, so this is based on the temperatures between 32 and 45. And we know some research they have done, some researchers, they have find out that, temperatures above 60.6 degrees or about 64, 65, they can counteract the chill hours. So when I look closely at the chill hours and the so-called warm hours at our site in spring, in the winter of 2022, you can see we have a few chill lights represented by the blue peaks. But between them, we have many warm days. So the temperatures are about, above 60 or even 64, 65. So, according to the researchers, any temperature between 6.8 and 4.4 can reduce chill unit by half point. Any temperature above 64.4 can actually, each warm hour can reduce chill chilling by 1 unit. So considering this, in Central Florida, maybe in some years, actually we didn't have any chill hours at all. So facing these challenges, we have been trying 3 approaches to overcome this. First is to explore variety differences, in chilling requirement. Second is that we use chemicals to help blackberries to break buds. And third is the breeding. So here, first I would like to mention the varietal differences in chilling requirement. So this is a table based on several researchers in Arkansas. Even though all these varieties, they were bred and selected in Arkansas. But fortunately, some of the varieties, they have pretty low chilling requirement, like 200, 300. So this is great. That's why, this makes it possible for us to do, to produce the blackberries commercially in Florida. And then also my colleague, Dr. Shinsuke Ajihara, so he's a physiologist. So he has been, using chemicals to induce bud break. So initially he tried the GA3, gibberellic acid, and this, growth regulator, actually they can induce bud break, on all the varieties, all three varieties he tried, and this treatment can increase yield substantially, especially on Navajo and Wachita, 5 to 9-fold yield increase. So this is good. But unfortunately, this treatment does work consistently among varieties. In this case, with Natchez, so actually GA3 treatment can cause bud abortion and reduce yield, even though GA3 can induce bud break in Natchez. But so then he tried the BA, which is cytokinine. This one seems not working in Florida. But we know there's some other cytokinin that worked in Mexico, such as TDZ. And then he tried the 4 chemicals to defoliate the plants and induce bud break. So including lime sulfur, 10%, and the zinc sulfate, 10%, potassium thiosulfate, 10%, urea, 10%. So all these chemicals, 4 chemicals, can defoliate blackberries in central Florida pretty rapidly, just in like 7 to 10 days. They can defoliate, and then 3 of them, they can induce bud break. So this is including lime sulfur, zinc sulfate, lime sulfur, potassium sulfate, and the urea. And then 3 of them, they can actually increase early yield, by several fold, like a 2-fold to 7-fold, 21, 23-fold. So very high early yield using this chemical treatment. But 3 of them can increase the total yield, I guess, to about maybe 15, to 20%. Lime sulfur can induce more. But potassium thiosulfate, actually, they can cause cane dieback and bud mortality. So currently, in Florida, in central Florida at least, he recommends us to use urea, 10% urea, or 10% zinc sulfate to defoliate the plant and induce bud break, and also to increase yield. So the cost for urea and the zinc sulfate is about $70 to $100 per acre. And in my program, I guess I prefer to use lime sulfur, even though it's a little bit more expensive, because lime sulfur can also kill the spores and the insects. So I use lime sulfur more often. But if you are interested, you can find more information using this link. Here has a publication. So in the next several slides, I'm going to summarize, the data from our variety trial. So in this case, all the data were collected using chemical defoliation, urea or lime sulfur from program. So among the 25 varieties we have trialed, Prime Arc Freedom has been, the top performer in central Florida. Again, I want to stress, it's in central Florida. So the plants are strong, many strong canes, they grow vigorous, and then they also have good tolerance of diseases in Florida. And then they are early to produce berries. Even in central Florida, we can harvest berry in early or mid-April, then finish the harvesting by mid or late May, before the rainy season starts. So this is great. I guess also the berries are big, attractive. The only thing probably, you notice, they are soft. They have color reversion. So, but anyway, in terms of yield and plant growth, so this is the best in central Florida. And in our trial, we can actually harvest up to like 19,000 pounds of berries an acre. So this is pretty good, yeah. And the breaks can, range from 8 to 10. And so this is the best one, in central Florida. And then Osage, this one without chemical defoliation and bud break. So the yield is, low. But when we use urea or lime sulfur, so the plants of Osage can respond well, so with a lot of berries. So in our trial, we have yield up to 10,500 pounds acre. So that's pretty good. And the berries are firm and sweet or sweet tart. And this plant seems yield pretty consistently from year to year. The breaks are from 8.6 to 11.7, which is good. So this is and then Prime Arc Horizon. This is a new release, last several years. So we have done 2 trials in central Florida. I think I like this because, they can produce a lot of berries. The nitros are big, fruity nitros are big, with many berries. So in our trial, we had up to, 10,000 pounds per acre. So it's good. The berries are firm and sweet, and the Brix are ranging from 10 to 11 in Central Florida, and most of the berries are marketable because of the firmness. The only thing, I guess they have some short songs, and in Central Florida, the canes are a little bit soft. Okay. And then Traveler, I guess this one we tried several times, but we see a lot of, cane dieback, and the plant seems to decline rapidly, at least in Central Florida. But this one seems to perform well in North Florida. And then Cato, we tried twice. This in Central Florida, and this variety responds to chemical defoliation well. With urea or lime sulfur, they produce a lot of berries, and berries are large, and the Brix are good. From 9 to 11, and the berries are firm. The only thing, the problem we have in Central Florida is that the berries are late in ripening. So normally we couldn't harvest until mid-May. And then the harvesting goes, into June, July. As you know, in Central Florida, once we get into June, then the rainy season starts. So we couldn't harvest the berries. So we lost a lot of berries with Cato. Then Panca, so this one, I guess I showed you a picture before, and this one also responded to chemical defoliation well. So with urea or lime sulfur, they can produce pretty well. And of course, everyone loves, Panca because the berries are, sweet, flavorful, and they are firm and they shape well. And actually, last year, we had yield up to 11,000 pounds with lime sulfur defoliation. So last year was a good year with Panca, even in Central Florida. This can do well in North Florida. And again, this one a little bit late than other varieties. So we lost quite a bit of berries in June, July, because they were late. And again, we have to use chemical defoliation in Central Florida. Okay, so that's it. Second approach, and then now the third approach is the breeding. I think our breeding is similar to the great breeding program in Arkansas, in North Carolina, or in other places. We focus on yield, quantity, eating quantity, shaping quantity. But I guess for us, the first thing we have to focus on no chill, no chilling, because of our warm winter. So we focus on no chilling, so they can better adapt to our warm winter, and also hot summer, humid, rainy summer. So that's something different from us. So focus on no chilling requirement. And also, because of our hot climate and the raining days, so we have a lot of diseases issue. So improved disease resistance is another focus for us. And the third difference is that we would like to begin to harvest berries in maybe early April, mid-April, so that we can finish harvesting by the end of May or early June before the raining days come. So that's the three differences. So far, we have evaluated about 25,000 seedlings. We put about 16,000 to the field, and select about 250. And then we put 65 in tissue culture to propagate them. So currently we have 7 breeding lines with a tissue culture company, and then we have 33 in growers trials, including several growers in Florida and several growers outside Florida. And pretty soon we have another 32 to be sent out to growers for trials. Okay. And here is the BL6. So this is one that have beautiful berries, very attractive, shiny, large berries, and also the Brix, can up to 15. So the berry tastes very good. The yield so far, the highest in our trial is about 12,000 pounds. And the berries can store well. So these pictures are from Tom Gardner, who is a great grower in Florida. Have learned a lot, and I think he's in the audience. So BL6, and then BL14. So this is a project of Osage. This one have very good berry. A little bit larger than Osage, and also can produce well, store well in Florida. And then last year we found several selections that have very high yield. 18,000, 24,000, even 32,000 pounds of berries per acre. So that means these selections they have very low chilling requirement. Because last year we have about only less than 100 chill hours. So under this environment, they can produce this much. That means they don't require many chill hours. So, and then we have some new selections have very strong pumpkin fruiting. So compared to Freedom and the Horizon, and some with very good hybrids, sweet flavors, some with crispy texture. So that's, I guess, a brief summary of my work on Blackberry. And this is a picture of Blackberries I took in 2016 in North Carolina, South Carolina. That's our aim. So we want some new varieties that can produce as well, like this. And this variety is from, Dr. R. Clark. Okay. As for raspberries, we just started 2 years ago, and then we have done a number of trials, and we see a lot of different varieties. So this, you can see, this is in, I guess, by the end of April. So the plants, some of the varieties have tall plants, grow vigorously. Some others only like 1 or 2 foot, tall. But these plants, they are 4 to 5, 6. And then we tried the 13 pumpkin varieties, and this 4, I think, seems to have good potential in Florida, even Central Florida. So this is a Crimson Night, Crimson Treasure, Coconut, Vintage. On average, they can produce 2 to 2.6 pounds per plant. And some of the highest producing plants, they can produce actually up to 5 pounds. So that's good. And you see some of the varieties, they start to producing, ready to harvest in late April. And then suddenly we have stopped on September 30th. Why? Because last year we had several hurricanes, so they just broke our plants. So we have to stop. So that means the plants they produce over the summer, in Central Florida, in our condition. So this is a Crimson Treasure, so from our trial in Central Florida. So this, I think, probably in maybe June we took the picture. So this variety have moderate vigor. The canes are upright, have good heat tolerance. And so this picture, the small one, I took it in hot July. So still have a lot of flowers, a lot of berries. So we see large fruit clusters, good fertility, and good yield. And then this coconut, so this one, the plants are vigorous, grow fast. So this is the first to have ripe berries, and then the berries are pretty uniform, and the flavors are pretty good. So coconut vintage, so this is one of the parents of coconut. This one can do also pretty well in Central Florida. The only thing I noticed is that the size seems to vary a little bit. So I would prefer coconut over vintage, but you can try in your field or in your greenhouses, or tunnels. And then Crimson Giant. So this one, I guess the berries can be very large, but some of the berries somehow they are small. So you see a lot of berry size variation, and we also notice powder mildew, and this one related to fruit. So that's the 4 we would like to recommend based on our trial. And then Crimson Night, this one, I guess the problem is that, come into, the berries are, ripen late. So, and also the hurricane damaged our plants, so we don't have a lot of data to share. So these are 4 to 5 Okay. As for breeding, so we started 2 years ago. So we make the crosses in greenhouse, germinate seeds in tissue culture. Then we grow them in beds like this. This is actually tomato field. So for the initial screening, so we want to, screening for, heat tolerance, disease resistance. And then we noticed, I guess based on our eliminated data, some of the selections seems to have good, plant survival, heat tolerance. After, June, July, August, September, we took the data in December. The plants were put in the field in June. So that's a brief summary. Our I guess, Blackberry, Raspberry research has been supported by USDA, Florida, Department of Agriculture and Consumer Service. And also our, I guess, two companies. We have great support from the growers and also my collaborators. I guess, thank you very much.
Okay, our next presenter is Dr. Zilfina Rubio-Ames. She's an assistant professor of small fruit and extension specialist at the University of Georgia. And she's going to tell us how to choose the ideal blackberry cultivar for South Georgia.
Hello, everyone. Thank you for joining us today. So I have the pleasure to talk to you about some research that has been happening in my group for a couple of years. I'm going to start first with some introduction of Georgia blackberry production, which is increasing year by year. When I started, we actually had like 800 acres of blackberry production, and as you can see now how we increased so much. And the industry mainly based on cultivating blackberries that were bred in Arkansas by our dear John Clark and Dr. Margaret Worthington. So our main acreage, as you can see, it's concentrated in South Georgia. And we have a very short season. So we usually, peak until mid-July. So when I spoke to some of the blackberry growers, they were trying to see if we can extend the season a little bit. And the only way to do that could be, by planting maybe other cultivars that require a little bit more chilling environment. But that is also, could be it could be risky because sometimes we don't get all the chilling requirements. So our most popular variety is Washita, and it's, the growers like that a lot because it's a high yielding variety. But, Caro, Osage, and Ponca had also been planted in recent years. And as I said, it's mainly older Arkansas-bred cultivars that we have. However, as you probably know, we have two other, as it was mentioned in the previous talk, we have two other breeding programs that are located in colder regions of the U.S. And the growers also plant Bone, that it's from North Carolina, from NC State, and that was released in 2013. And there were also some other cultivars that were bred by Cherfin and Michael at the USDA in Oregon. So when I started in this position 3 years ago, I was trying to see if we can maybe do a variety test and trying to see how all of those blackberries that are already planted and are already liked by the growers compared to the ones in Oregon, and how will the Oregon cultivars will adapt to South Georgia, and also comparing Washita to Bone and all the other Arkansas varieties. So as you can see, this is the newly released cold hardness map by the USDA. And you can see there on the on the red circles, all where the breeding programs are, and here is where we are. So we are located in a different cold hardness zone, and we also have different chilling requirements, so that definitely is going to affect the plant phenology, and that our previous speaker did a wonderful job explaining all of those things. But also, as I mentioned, the Arkansas varieties are developed, that are very well planted in Georgia. But when we looked at the growing season and the growing conditions that in Georgia and Arkansas, they're very different. As you can see, the June temperature is different. That is the when we start, harvesting the fruit. So it can also impact fruit quality. We have different precipitation as well. So based on all of these, what I'm going to talk to you is about two two projects. So the first is evaluating the phenological stages of 10 blackberry varieties that you have there. So coming from the Arkansas breeding program, the Oregon breeding program, and North Carolina is represented by Vaughn, the Vaughn cultivar. But also, since the growing conditions are very different from Arkansas and Georgia, we did some sensory evaluation, and we conducted this for about 3 years. I'm going to show you only 2 years worth of data, comparing Washita to the other planted blackberry varieties as Caro, Osage, and Ponca. So we're going to talk about the first objective first, how all those Oregon varieties, those North Carolina varieties behave in, warm, hot weather, in hot humidity in South Georgia, and also how, Vaughn performs under those conditions, and we're trying to kind of like compare it to the already planted cultivars from Arkansas. As you can see there are all the phenological stages that we evaluated. So we set up this plot 2022, and we have all of these varieties planted in the Alapaha Research Station. And we went and tagged 3 plants per cultivar, and we had 5 replicates for each. We start the measurements and look at each phenological stage that you have there on the picture from February 22nd to April 25th. And we looked at 12 inches below the apical, the top of the floricane, and we assessed for each of those developmental stages. As you can see in the picture below, we tag every plant, and then we start counting from the here all the way to the top. So there, our results, what was the cultivar that broke dormancy earlier? In here we have Osage, as you can see here. We decrease on that percentage of dormant buds, and then we continue decreasing here. That happened on March 7th, followed by Ponca, Washita, Caro, and Vaughn, so it's something that we expected. We didn't have the data, or we don't have any published data on how these cultivars perform in Florida, in Georgia, I'm sorry. We don't know, when they're blooming. We didn't know when they start setting fruit. So this was kind of like trying to educate ourselves so we can educate the growers on what in each, phenological stage of these cultivars. As you can see there, one other thing is that Prime Arc Traveler, right here, it kind of like behaved very different compared to the other Arkansas varieties, so it kind of like had an inconsistent bud break. Twilight, surprisingly, performed very well, and broke dormancy earlier than Galaxy and the other, and Eclipse, and so that is what we got here. And then these were the temperatures that we had from November and all the way to April. And when we look at the chilling accumulation, we had, on that year, we had about 736 chilling units that were accumulated. So it was enough for the Arkansas varieties, somehow was enough for Galaxy. And at the end, the last week of the evaluation, as you can see there, each picture on the bottom here, how was the last, how each Osage looked here at the end of the evaluation. It had already set fruit. But if we compare it to the other cultivars from the northern climates where we require more chilling accumulation, you can see how Twilight, Vaughn behave. Sorry, I think I said Galaxy before. It's Twilight and the one that set fruit by the end of that by the end of the evaluation. And in here, we developed this graph, kind of like looked into like when everything starts breaking dormancy, when we bloom. As you can see there, we kind of we couldn't see the blooming, we couldn't catch the blooming on Prime Arc. From 1 week to the other, we went, and because these were weekly evaluations, we went and Prime Arc had already set fruit. And this is, you can see, that how the other ones start blooming and what is the differences in the phenology of each variety, which is, very similar, and they're all like one after the other, all the Arkansas bred cultivars. And here we have like the colder climate varieties, and you can see there. So you can see Bone on the top. It's had already set fruit by the last week of evaluation, and the same with Twilight, but the other Oregon varieties were still, pushing. So in summary, chilling units accumulated in Alapaha since they were sufficient for Osage, Ponca, Washita, and Caddo, as kind of like was expected. Prem Arc, Osage, and Ponca were the first to set fruit. We didn't catch that the Prem Arc Traveler blooming day. Bone was blooming in April and set fruit at the end of the evaluation, which was April 25th. So Twilight bloomed in April 18th and set fruit by the end of the evaluation, which was April 25th. And the other Oregon varieties, had some signs of flower bud development and flower opening. So the second objective, it's the sensory evaluation and some physical chemical attributes of the four Arkansas bred cultivars that are grown in South Georgia. So in here we have, what we did is that we had 3 harvests, and the fruit was stored overnight, and the following day that sensory evaluation took place. And then we also stored this fruit for 7, 14, and 21 days. So we evaluated several physicochemical attributes, but I am going to only present the red drupal reversion assessment and the consumer taste panel. So we use a scale, we develop a scale to evaluate red drupal reversion. So when there was no red drupal reversion, we have 0 affected druplets. Low incidence was from 1 to 2 druplets that had the reversion. And then the high red drupal reversion, we had more than 3 or more druplets affected. And this is very important because, this can, affect their consumer preferences or the buying of their consumers at the store. So we did 3 sensory evaluations. We used a non-trade panel. We had about 16 panelists in each sensory evaluation, and we used a 9-point hedonic scale to measure all of this. So I'm going to show you that RDR presence first, and then the sensory evaluation data. So in here at harvest, Washita had a higher incidence of red drupal reversion compared to Osage. And then 21 days after storage, Washita still had a higher incidence of red drupal reversion, and Caddo had a lower incidence of drupal reversion. In harvest 2, we kind of saw the same thing. Washita always had a higher incidence of drupal reversion. And however, by the 21 days after storage, Washita had decreased on that. And if you can look, Caddo had the lowest, had the highest at incidence of red drupal reversion. In harvest 3, we had, similar again, Washita having the higher incidence of red drupal reversion. For taste panel, as you can see, Washita had the lowest score for overall flavor. However, for sourness, there were not any significant differences. Caddo had the higher the higher rate for sweetness, as you can see right here. And of course, Caddo had a higher rate for size because Caddo is a large berry. And for the taste panel, for the second taste panel, we didn't see any significant differences on overall flavor, overall appearance, sourness, or sweetness. So we're trying to figure out what happened that day that we did not see any significant differences as we did on the first harvest. And what we saw is that we had a highly precipitation in that day. So we had rainfall a day before the harvest. So that actually affected the results from our second sensory evaluation. On the third sensory evaluation, again, you can see how Washita had a lower score in overall flavor, and also had a lower score on sweetness, and on size, Osage had actually a higher size than Caddo. So some summary on that on the RDR. So we had a higher RDR incidence in Washita for all the harvests. Osage and Caddo had the lowest presence of RDR. Ponca had the highest RDR presence after 21 days of storage. Some sensory evaluation, so the harvest 2, as you can see, we didn't find any significant differences on the sensory evaluation, and this is due to the rain events. So rain, before the harvest usually definitely influences the quality of the fruit, even if we wait and harvest the next day after the rain. So Caddo was kind of favor in most of the sensory survey. So I didn't present any research on firmness, but the firmness in Caddo, Osage, and Washita displayed significant improvement over the storage time. So they had performed better on firmness. And there were no significant differences during the storage time for total soluble solids, which is TSS. So with that, I want to thank NARVA and the Southern Region Small Fruit Consortium and our grower cooperator, the Polk Farms, for allowing us to do all this sensory evaluation, and the students Orestes and Ramsey that did a lot of this work, and my lab that are there. So with that, I'm open to any questions. Yes.
Did you say you measured?
Yeah, sure, I'll do. Excuse me.
Did you say you measured decay at like 21 days of storage?
Wait, the student did, I think, measure decay, but I don't think, I haven't analyzed that data. I think it did, but I'm not 100% sure, yeah. Any other questions? Yes, hi, Penny.
So I'm curious, you have sourness and sweetness in your sensory profile. Has anybody come up with a way to put those two together to kind of give you an index?
Oh, like,
Because both can affect perception.
yeah,
I'm curious if anybody's gone that far yet.
no, sorry. Well, maybe we can look into that approach. We're gonna repeat this sensory evaluation this year. Yeah.
Did you see a difference in the harvest window for the celestial series?
Yes, and I actually have a slide on that. Let me show you. It's not clean data, but you can see there. Let me see. So if you can see there, this is a very hard graph to see, but this is at twilight right here. So you can see the bar coming here. So we did harvest, so you see here, we did harvest fruit from the Oregon varieties. But then, the rain started, and then we just stopped. So we do have some yield data that probably have, be able to present next year. But yeah, as you can see that we harvested from Eclipse in June 13, and also from Twilight, and then we continue the harvest from Twilight until the 7th, so July 2nd. So, and then, so we did, that's kind of like when the Oregon varieties start the harvest. Any other question?
So our last presenter before the break is Dr. Aaron Cato. He's an IPM extension specialist at the University of Arkansas, and will be talking today on mite management of caneberries.
Yeah, I appreciate the introduction. So I think I've spoken in this session a couple years in a row now, and so last year I talked about some of the more hard research we did on broad mite, but we've been seeing a lot more types of mites that are pretty injurious to our blackberries especially, but also in caneberry or other caneberries, we have a little bit of raspberry where we are. And so I wanted to talk to you about some of the newer pests and mites that we're seeing, and also kind of some of the efficacy trials we've done to see what works, because not all miticides are created equal. Not all miticides are going to work when you have 5 times threshold. So things like that. And so, you know, if you have any questions, definitely let me know and we can try to talk through some of them. But this is work that my master's student, Jared Lynn, did, some of it, and then Ryan Kiefer, he's runs a lot of the day-to-day of the program. He did a lot of the ratings and stuff on the data that I'm going to show you, so definitely wanted to call them out for it. So what all mites are we seeing in our caneberries? And once again, we primarily work with blackberry in Arkansas, but we see a little bit of raspberry production starting to crop up more and more. But spider mites are probably the one that's the biggest issue on raspberry, but we're seeing more of in blackberry. So you can see that picture on the top right, that's actually some, I think it's Vaughn, that variety where we're seeing a pretty good bit of spider mite damage, and it generally starts sometimes towards the later portion of harvest, kind of when Vaughn's after its peak, and so it's really damaging some of the priming canes, but we haven't seen too much injury from it, but enough to warrant a miticide, but not enough to really see too much of an effect later in the year. But this is primarily two-spotted spider mite. There are some other mites, spider mites in the mix, but this is primarily what we're seeing. You know, I think it has a lot to do with some of the extended droughts that we're seeing in the summer. We have real, steady weather, so we're not getting a lot of the rainfall in Arkansas that you may see in some of the mountain areas of maybe the near Asheville, places like that, western North Carolina. But we get to periods where we'll go a month and a half with no rain, and it's in the mid to upper 90s the whole time, and so that's really good mite weather. It may be really humid, but it's still good enough to where they can build up. So we think that those extended droughts are why we're seeing more of an issue in blackberries. Anything in tunnels, we see a lot more of a problem with spider mites because you're creating that arid or at least more stable environment that we're not going to get the rainfall that's going to, or help a lot of these pathogens that help knock down mites. Broad mites are the newer pest to caneberries in general. It's a worldwide pest at this point. We first saw it in Arkansas in 2007. That would be, I said first found in 2012, but that's field-grown blackberries. We had it in high tunnels before then, and I think a lot of people did. But in the field in Arkansas in 2012 was the first time it was found in blackberries. And so since then, all the way up and down the southeast, it's a problem. California, it's a problem. Mexico, it's a problem. Europe, you talk to them about all their production, it's a problem there. And so it's a pretty widespread issue. So we call it an emerging pest because we're still trying to figure out exactly the best ways to manage it. We went to some farms with some of the folks from western North Carolina this year, and we found out some growers are just spraying before they find it, which I think it's a good pest that you can see and then knock down real easily, so it's not one that I would recommend that for, but we'll talk more about the control strategies. Some of the newer pests on the block, and I say that because, in western United States, the red berry mite's one of their big issues. But I don't know that I've ever confirmed it on our side of the Rockies, at least our side of, or close to the Mississippi or across it. We get pictures like this one up here all the time. But the big kicker with red berry mite is that red portion will never ripen. And so those portions will actually stay that way, and you'll start to get over ripeness on the other side of the berry. So there are some differences related to climate or weather in ripening on fruits. And you can maybe ask Hassel Carmen, I think I saw her walk away. Like Ouachita, we see a lot of times where you'll get half the berry ripe and then it'll catch up. And that's not red berry mite. This is red berry mite right here, where you have completely unripened fruit right around, ones that are ripe at the same time, and that's the portions of the fruit they're actually feeding on. And so we have found the mite here, but I think they need very arid and stable climates for them to really impact the fruit in ways that are going to be a problem for you. Newer areophyte mites, ones we've had for a while, that would be the dry berry mite. I think it wasn't in the system that it was found in our area, and so USDA got in a big mess about it this year because they found it in Arkansas, right? Well, it's been in Arkansas for a long time. That's an issue on raspberry in the West Coast, kind of like red berry mite is, but we have it. We sampled a few places and found it, but we're not seeing any impact from it. But the big thing is that, some researchers at U of A, some of the virologists kind of did some research that said that, or suggesting that a sister species to that, parviflora, actually can transmit viruses directly. So the disease that you see can be directly transmitted, which has never been found before in blackberry. We've always told you yellow vein disease is multiple plant viruses stacked on top of each other, right? Well, now there's some suggesting that you take a blackberry plant that has no viruses, you put these areophyte mites on it, they found yellow vein disease on that. So now they're calling it leaf mottle virus and saying they think this areophyte mite can directly transmit it. Well, the problem is we've looked around and these guys are all over. And so It's just more research needs to be done. But for our kind of place, we're doing miticide trials all the time. We want to see what are our miticides currently doing to what's out there in the field. So that's kind of what I'm going to share with you all today. So first, let's go a little bit into broad mite because we've done a lot of research at Arkansas on it. So, first observed in Arkansas in 2007 in high tunnel berries. They were looking at the first primocane fruiters, trying to see how well they would do. So they put them in tunnels, and then boom, they had broad mite right away. And then they started seeing it in the field about 5 years later. We think that a shifting climate's probably made them a bit more of an issue, but also once we got into spotted wing, that's when I think they really blew up because all of a sudden you have a spray schedule of broad spectrum insecticides every single week after they're starting to get rolling. So you're knocking down predatory mites, you're knocking down anything that's going to be preying on them consistently. And so we've had some plots where we didn't spray and it's nothing replicated, but we just decided we weren't going to put out a bunch of insecticide and we don't have as bad broad mite. And so we think that's something to do with it. But if you can tell me how to get away from controlling spotted wing, maybe that'll help, but I doubt it. It's microscopic, though. It's hard to see, even with a scope. There's some pictures there, but ultimately, we figured the damage really is what you should look for. It looks a lot like oxen injuries. You get a lot of leaf rolling, and then your terminals will kind of point straight up and go kind of a golden color. A lot of folks have it and don't know it. We'll go out to their fields, and they'll say, yeah, it's heat stress this time of year, and then you look down, and they're definitely over threshold for broad mite. So what's the effect of broad mite on blackberry? The biggest impact is primocane fruiting because they only feed on the primocanes. And so if you get these things, say in like June, July, they will eventually feed on developing buds, flower buds, developing fruit, and they will directly impact your fruit loss. We primarily grow floricane fruiters in the southeast, and so what's the impact there? We did a few trials and didn't get great data on it. We couldn't see a direct impact, but what we've seen in some is, like especially if you plant this year and then you get broad mite bad in the summer, we've seen plants die to the ground. So we know that they have the potential to really hurt plants that aren't maybe planted a little late, things like that. We've seen instances where the buds they fed on, the bud sacking, they don't emerge. Now, when you put this across the trial, it's replicated. You got to hope that you get a bunch of broad mite, and we didn't get the greatest numbers in our trial, so we didn't get great data on it. But we've seen some spots where we've seen complete tip dieback, and so we think that the floricanes can get to levels where they're pretty bad. And so this is a good example. Fields where you see multiple feet of your primocanes dying back past to where you'd be pruning them off. That's going to be direct yield loss the next year, depending on how much growth you have before. So it could be a combination of factors. So what are our recommendations on broad mite? So, we recommend to scout for the symptomology. You can look for the active mites, and that's what if you're a primocane fruiter grower, you're going to have to look for mites because you may not see any symptoms and you may be at enough that they're going to affect the maturation of your buds into flowers and things like that. And so you're going to be needing to pull leaves. We recommend pulling like the third terminal down. So these first unfurled leaves right here, you pull those, look at them under a scope, and then you're looking for these polka dotted eggs, and then the adults are going to have this like almost hourglass type shape on their back. My graduate student, Jared Lynn, he actually developed a scale for visual sampling. And so we were getting a lot of questions where growers were saying they were waiting to see injury and then they'd spray. And so then we just said, okay, we're going to sample tons of places. We're going to look at the number of mites, look at what injury we saw out there, and does it correlate? And what we found is, yeah, it does. And so if you see this in your field, you are probably at threshold. If you see a little bit of upturned terminals, you may be under threshold, but we never really had this levels of injury and weren't getting to threshold. And that's about when you hit it and spray it. So it worked out pretty well, we think, to where if you're starting to see this pretty consistently, you're going to have to spray. And so we would call that like a 3, where you're starting to see the twisted leaves pretty consistently, you're at threshold. And that's just some of the summary of it. But I'm not going to go through it too much because I've showed it last year and I can talk to you again if you need to see it. But control options, the thing about broad mite is it's not a tetranychid mite, it's a tarsinid mite, and so not everything works. And we've actually looked at more things that don't work that do, and so miticides. I would say that we're lucky in that the best miticide is the cheapest and easiest to find for us anyways, which is abamectin. And so that's always been our standard product. But the big issue with abamectin is the 7-day pre-harvest interval, right? So if you're a primocane fruiter grower, or if you're late into floricane fruiting and it's starting to really hit your primocanes, you have to wait to spray. And so we've done a lot of work trying to look at alternatives that have like a 1-day PHI or things like that. So in 2022 and 2024, we did a lot of trials on farm with high populations that I'm going to share data from today. So in 22, we had our first trials were on Navajo. So we have two different trials, and I'll explain to you on the graph, but basically we sprayed each one twice. We had one trial we put out, and then we got another product in the mail finally, so we put another one out next to it, and you'll see why we don't have Magister in the first trial versus the second trial. We wanted to look at it, but we didn't get it in the mail until a week later, and we wanted to spray it. So in the first one, we looked at Acel, which is acetamiprid, Savvy, which is hexythiazox, Portal, this is fenperoxamate, and then we had a biological someone wanted us to try, so we tried it. It's like Spear T or Spear Lep, it's the same thing, but it's a biological. It's like a spider venom-based product. There's some suggestion it works on mites. I'll show you if it worked on ours. And then Agrimec, which is we would say is our standard ivermectin. In the second trial, we finally got Magister in the mail, so we just put it out. I think it was about a week later, or 2 weeks later maybe. And so there we just wanted to compare what we were trying to see is, did Portal, which is a one-day PHI, how did it compare to these two known good products, which is Magister and Agrimec, that both have a 7-day PHI. So at the time, these were our 3 labeled products that we knew we had. Portal had just got a label, like just right then. We didn't know if it worked. And we know it worked in pepper, but we didn't know if it worked in Caneberry. So here's from the first trial that I talked about. And so you can say this is right before we sprayed, 0 days after application. This is just the number of broad mite adults and immature, so we would say motile mites. This line here is the threshold, so you want to spray between 1 to 5 mites per leaflet, and you can see we started out about 4 or more times threshold, so the numbers were high. And you can see what happens when you don't spray. They keep going up. All the way up, you can see our untreated got up to 70 mites per leaflet, so you're looking at 14 times threshold. That's where you're getting good tip dieback. Blue line here, that's going to be our ivermectin. You can see that it decreased. We got out to 7 days after. We always see really good suppression with ivermectin to 7 days. And then it just slowly works its way up until about 2 to 3 weeks later, we always see this big jump. And so we sprayed again. Once we saw our data, we actually went out and saw that we had pretty, our symptoms were coming back in our known standards, so we sprayed again. As you can see here, 3 days after our second application, 7-14. So you can see this is what we would consider, you're going out 3 to 7 days later, what actually worked. Ivermectin did its job, but Portal also did a pretty good job. It knocks them down. But you can see Portal, it comes back. But if you're during harvest, or you're in late post or of your primocane fruiters, or your late harvest on your like Vaughn, Navajo, and then our new one from Arkansas that I'm blanking on the name on, someone will yell it out. You can see that this would be a good product to knock back the population. Same thing when we sprayed again, it knocked it back and it bounced back a little quicker. But then we got oversprayed at that point, but it was so late we already had all the data we needed. So what we found from this was that Portal was a pretty good alternative, especially considering its 1-day PHI. Can't spray Portal twice in a row though. I believe it's more than 14 days between 2 applications based on the label, so it has to be rotated. So really you got to wait till you get a population to use it or you're going to be off label. This is just looking at the injury rating. Remember I said between a 2 and a 2.5, that's about when you'd want to spray. And so we were somewhere around the end, and the numbers were, like I said, around 3 to 4 times threshold, so they were starting to pass it really quickly. So we sprayed there, and we kept it under that mark with ivermectin. Then you can see it started to work its way back up. We sprayed again, and it's harder in like a small plot trial to really glean too much because some of these plots are right next to untreated, right? And so there's a lot of bleed over. And so I would expect this to probably flatline or go down. Everywhere we've ever put out ivermectin on broad mite, it wipes them out pretty quickly for at least 2 to 3 weeks, but they will bounce back. But you can see Portal, it came down to about the same and then worked its way back up. And the 2 applications, it still was up on this 3.5, so we were starting to see some necrosis even with Portal. But if you would have used it and then rotated with maybe ivermectin or Magister, if you were out back towards the end of harvest, then you could have maintained it low. So this is our second trial from 2022. This is just the 3 products, and you can see Magister and ivermectin look real similar. You only get 1 shot of Magister a year, which is why, and it's harder to get for us. That's why most people don't use it. But it looks real similar. Ivermectin just always has a bit of it just looks a little better in our trials every time we look at it. But we only sprayed this one once because I think we applied it the same day as the second one. But you can see Portal looked exactly the same in this trial as well, and it was just a few rows over from the first one. Then everything kind of declined this is getting towards the end of the fall. And here's just the rating on that. You can see we sprayed it way later, so everything continued to go up, so we didn't spray it until it was well past. And all 3 products were starting to get things back to where they were recovering. 2024, we actually did some trials on Vaughn, and we were real blessed this last summer because we had above threshold populations of both broad mite and spider mite in this location. So we were able to get really good data on both. I have these bars in red here because they are not labeled, and so this was part of an IR4 trial. They told me it was fine to put it on after fruiting as long as they weren't going to pick any fruit this year, but next year it'd be fine afterwards. But so it was on a commercial field, but IR4 said it was on label as long as it was through fruiting for the year. But you can't go out and use Nealta on your crop. So I'm just trying to make sure y'all recognize that. We had two labels of Nealta, or not two rates of Nealta, one with a non-onyx surfactant, one without. Then we looked at Portal, Agromec, Magister, all the same, but this time we were able to include Zeal and Acromite, which are two different modes of action, or one different mode of action, but two different products that you can get your hand on. Everything was with the surfactant. Everything we do for these mites are with the surfactant because it's really hard to get in between the veins to get with them. And so we've tried spraying Agromec without a surfactant. Can't kill any. It's amazing how much the difference is. We also sprayed these twice, and I'll show you, but it's for a different reason. We sprayed the first time and couldn't get them under threshold, so we had to spray again just to even start to get them knocked back. I'm going to show you the broad mite data first, and then we'll get into the spider mite data. And I'm not as happy with the spider mite data, and I'll talk to you a little bit why. But the other thing is, this is 3 months after this paper came out about these aerophyte mites starting to spread this virus. And so what we were able to do is count the aerophyte mites as we went through, and we found way more than we thought. There's a lot of papers that suggest they're just in the bud scales. They're not in the exterior canopy. But we actually took leaves from the interior canopy, and we used those with the mite brush for spider mites, and then we pulled leaves from the exterior for broad mite, and we looked for aerophyte mites on both of those, and we found them primarily on the outside. And so that's the data that I'm going to show you. So we were actually finding them alongside the broad mite. And once the aerophyte mites became a problem, people asked me, have you ever seen them on leaves? And I said, we've looked at thousands and thousands of leaves of Blackberry over the last 5 years. Yeah, we see them every single time we look. So they're out in the canopy throughout. I mean, we start looking for broad mite in June all the way through October, and we find them the entire time. So they're out there. Not 100% sure what we're doing. There's some suggestion they're spreading some viruses. We're not 100% sure yet, though. Okay, so this is going to be broad mite motals per leaflet. So you can see it's kind of all over the place, but that's what you expect when you're across. I think these were like 25-foot plots, down rows, so 4 different rows, and so you get a little bit of variation in there, but anywhere between 3 times threshold up to 5 times threshold. You can see the different colors, and if it has a star, that just means it was different than the untreated check. And so at 2 weeks, it knocked them down, but everything went down a bit and then recovered, but we couldn't get a difference yet from our untreated check. So we had to spray again, and they bounced back really quick, kind of how we saw them before, but it's the same story. Avimectin looked the best, Magister looked second best, Portal looked a little, not quite as good, Portal bounced back quicker, and then they all dropped back down, and so we got the exact same data 2 years apart. So we think that's pretty well what you should expect on your farm as well. Sprayed again, and you can see Avimectin and Magister almost zeroed them out. They did for a week after the second shot, and then they started to recover. These broad mites are moving back in from other rows and other plots in this case. We don't see recovery that quickly whenever a grower spraying the whole field. Here's just the eggs, and so we saw a similar thing with the eggs, and you wonder sometimes because things like Avimectin are more likely to kill the motals, and they don't do a great job of controlling eggs, and sometimes that translates into more adults anyways, but we just counted eggs the whole time, and it was the same exact thing as the adults. Here's the injury rating. You can see the only thing that all 3 products were able to get it back around threshold, but Portal was always a bit higher than Magister, kind of took a peak there at the end, but that was 3 weeks after 3 weeks after the second application. So here's spider mites, and I want to point out 2 things to you. One, nothing separated in our spider mite trial. And I think the reason that it did is because we randomized like they teach you to do in statistics, and they're like, you really want to make sure you don't force randomization, you want to make it truly random. We went through and rated it. It looked like everything was pretty similar, and then we come out and look at the average mites in our untreated check. We chose 4 plots that randomly happened to be the lowest plots in the entire huge field that we looked at. And so we're chalking this up to a little bit of just bad luck. I don't know. It looks similar, but the numbers were just way lower in those plots. And so you can see the untreated, this blue line, it recovered the entire time. Everything else stair-stepped down, but that untreated kind of, it was the only one to go up besides, I think Magister kind of took a little peak. But we really couldn't glean too much from this. We think everything was probably lower in the populations, but the untreated being so low, it's hard to compare it to anything. We looked at eggs as well, and you can see once again, untreated was the lowest by far. It actually was significantly different in a pre-application sample than Portal was. But you can see the only thing that we didn't get good egg control in was actually Magister, which was, even though that in the second week they were similar, those kind of stayed the same, and again on week 5 after the second application. So we didn't get good suppression of eggs with Magister. Here's the injury rating, and just to tell you what we did was we just rated based on how much stippling we were seeing. So 1 was none. We didn't see that anywhere. You can see that the very lowest we got was widespread stippling is what we said. We're trying to look for this transition of like leaves falling off and webbing is what we would say is the spider mite's kind of getting a bit worse, but it all just kind of stagnated. It started raining a bit and it started just kind of stagnating, and so we didn't really get too much of a difference. You can see we got an increase with most things. The untreated just kind of stayed stagnant though, or the agamec did actually. The agamec dropped down, so there wasn't too much we could glean from that though. We also counted the number of predatory mites. We really wanted to see which miticides were impacting their populations. Well, we found a ton of predatory mites, but there were a lot of mites for them to feed on out there, so you would expect a lot of predators. But you can see zeal kind of started with the lowest. It did the same thing, kept low. And I've always been told that zeal was a bit lighter on predatory mites, and I don't know if this is really saying that that's the case. Nothing really looked great compared to the untreated, and so I don't know that we saw a huge impact. There were so many mites to feed on that it was a great place for the predatory mites to be. The last thing is the aerophyte mites, and I'm not aware of too much information of anyone showing that any miticides that do a great job on aerophyte mites, but we actually got a little bit of separation with 2 of our miticides, and so the same ones that do a good job on broad mite look to potentially suppress aerophyte mites as well. Now, starting off, I think what we're showing here is that it's probably just that when we spray a bunch of miticides, we make aerophyte mites worse, and so maybe it has something to do with killing predatory mites or something like that, or just displacing some of the things they're competing with. But our numbers went way up. You could also say that maybe this is just looking at the shift in where the population is in the canopy. Maybe when we started, there wasn't very many at the tips, and they moved to get on the bud scales closer to the tips of the plant. Not 100% sure, and I'm actually on some grants with Lorena Lopez at NC State, and we're going to try to see where the aerophyte mites are going, because we're not 100% sure where they're at each time of the year. But what we did see was that they did get knocked back by that second application in agamec and in Magister. And so you can see they just kept them from rising, and agamec actually went down, but then they immediately came back. And so there was a ton out there, though. I mean, we're up to 140 aerophyte mites per leaf foot. There's a lot. So in conclusion, for broad mite, agamec, Portal, Magister, they're all good options. Portal being the lesser of those, but the only one you're going to use around harvest. Many places are going to need 2 shots. Most places that have broad mite issues, they'll get 1 bout of it like early August and then again a month later. And then if you're a month or still from dormancy, you can see a lot of early leaf drop if you don't do something about that, which we've seen can cause issues with overwintering and other losses of yield from that. And so you don't want your blackberry plants to shed leaves early. We know that that's a problem. Spider mites, our data is inconclusive. I don't know that we can glean too much from it. I don't know if it's just because we were at 4 times threshold. I've had growers spray every single miticide under the sun on strawberries and not get a hold of them, just depending on the year, depending on how bad it was when they started, so it could be part of that. But I think it's probably just mostly that our untreateds ended up in the lowest plots. And it's hard for us to tell without doing a bunch of pre-sampling. And broad mite, we've never had to do that, and we've always been pretty lucky that they were uniform. But spider mites, somehow it was not uniform enough. Aerophyte mites, they got worse as the trial went on, and the second spray really increased the numbers, except for an agarmite and Magister, where we saw some suppression or kind of stagnated. We don't know if the increase was due to a natural shift in the population, or are they moving to the bud scales on the tips of the plants? We don't know. If you read a lot of literature, you'd probably think that they would go more interior. And that's why we thought we'd see more interior leaves, but it just wasn't the case. The agamec and Magister did the best job. But the biggest thing to think about with mites is rotation. So you may look on here and see that agamec was the best option in broad mites. It seems to be a decent option in spider mites, but it's also very, very prone to resistance, especially in spider mites. I'm from cotton country in Arkansas. You spray agamec one time, you will not kill them with the second shot. Those resistant ones don't generally make it through. They don't overwinter well, but in that year, the second shot will not work. We've had people spray 3 times, and they just have dead cotton because of it. We've seen the same thing in strawberries in Arkansas. You have spider mites real bad, you put out Agrimec, it'll knock them back, but the second time you spray it, you're just pouring gas on a fire at that point. And so I think with all of these miticide products, these arthropods reproduce very quickly. Sometimes the miticides can actually increase their reproduction rates. It's a very common phenomenon. And so you want to make sure you're rotating modes of action, so that IRAC code that you're reading on there. You know, if your PHI is an issue, I would say you want to try Portal and then get to a point that you can try Agrimec next. For broad mite, I think it's going to be very similar for spider mite. PHI is not an issue. I tell growers every single time, spray ivermectin and see if they bounce back. If they do, depending on how early you have ivermectin, make sure you have Magister or Portal on hand. Don't use it again. But with broad mite so far, we've had a lot of folks use it Agrimec twice in a row, and we've saw no issues of it not working the second time. But we know in spider mite that's the case. So if you're trying to control spider mites and you don't have broad mite, I would say, you know, consider adding acromite or zeal into the mix. But that didn't work at all for broad mite. And so I would not recommend using acromite or zeal for spider mites if you have a broad mite issue as well, even if you're not seeing them yet. Try to use something for spider mites that's going to nip your broad mite problem in the bud as well. So that's all I got. You know, thanks to Jared and Ryan and Matea and Jenny, and I left off Jess in there, all the interns and the graduate student, and our Ryan's my program associate who did a lot of the scouting and rating and the hard work, I guess. And so, you know, we have a lot of information online if y'all want to find it. We have a podcast we do with the Southern Region Small Fruit Consortium. We have a YouTube video. We put a lot of stuff, or YouTube account. We put a lot of stuff up there. I think Amanda has the Blackberry School. We have, you know, building sprayers and all kinds of stuff. And then there's also, don't forget about the Southern Region Small Fruit Consortium guidebook. But I'd be happy to answer questions. I think we started early, so. Yeah, I've never found broad mite in raspberry, but we have, we'll look this year because one of our spots where we have bad broad mite, they just put in some raspberry. The other location where we have a good number of raspberry, they've had broad mite before, but not recently. And so I haven't had the experience on it, but spider mites every year. Early in the spring, you know, kind of how you see it on strawberries, we will go out and see them on raspberry. I haven't gone to raspberries yet and not seen spider mites. We have people thinking about it. It's just out in the field, and so they're trying some of these new, like European varieties that are supposed to be heat tolerant, and so all of those, they seem to still get bad spider mites in our climate, anyways. Yeah. So it depends on the year you looked at. The first year, it's because we got oversprayed by the grower, which happens all the time, and so it's just because the whole field got sprayed, and I think it was the day before we sampled one time, and then, or maybe 2 days, and so it hadn't dropped all the way, and the next time there was nothing. And so that's just, you could go out there and look at there. The other thing is just how late we're doing it, and so there's natural fluctuations in these mites. Broad mite, it gets real bad, and for us, mid-July, August. I've heard earlier in North Carolina and Western North Carolina, which we would think it would be the same, but they get it in May. We've never really seen it too much. But even in Arkansas and South Arkansas and tonals, we'll see it go up and then come down and then go back up and come down on its own. Now, I've seen it kill plants before it goes down, so I don't ever want to bank on that. But in these trials, I think towards the ends of the trials, you watch that untreated, you can see that some of those mites are moving down to get into the leaf litter where they're going to overwinter. And so the first one, I think that was October by then, so we're getting close to our first freeze at that point. The second one, we didn't see as much of a decline because we finished that one in September, Ryan? The one this year? It felt like it never ended, so I don't know. But I think it's a natural progression of the mites, and they're not very well understood. Dr. Don Johnson did some work before he retired on them, and they found they move into the leaf litter. But it just depends on the temperature. They're really climate sensitive, and so we've seen them injury all the way out to the end of October. We've seen them kind of not bounce back again. So August and then never again. It's just year to year, it's really different.
No more questions? Eric, one more time.
All right, everyone, we're going to go ahead and get started. My name is Amanda McWhort. I'm a horticulture specialist at the University of Arkansas, and I'm going to be your moderator for this session and also your first speaker, so I'll do my best to try and keep myself on time. This is going to be a quick overview of some of the work that we've been doing on nitrogen management for blackberries. And I will encourage you to stay tuned because some of this is still being finalized, but I want to give you kind of a preview of what some of our preliminary results have been. So we did a nitrogen rate trial starting in 2021 on Ouachita, where we were fertigating Ouachita at several different season-long rates with the idea of can we update what our previous nitrogen recommendations have been for the southeast on a variety that's really widely grown. Our previous recommendations have been 60 to 80 pounds of nitrogen for season-long nitrogen rates, and those were kind of developed from work that Dr. Bernadine Strick did on the West Coast on Western-style blackberries, and so we just wanted to kind of verify, is that also working well for Eastern type of blackberries in the southeast? And so we went in and fertilized Ouachita blackberries over 3 seasons at 0 pounds of nitrogen per acre, 30 pounds of nitrogen per acre, 60 pounds of nitrogen, all the way up to 150 pounds of nitrogen per acre. We were fertigating with ammonium nitrate, and then we used a standard rate of potassium across all of those treatments. And this was led by my graduate student, Dr. Amanda Leigh Walters. What I'll say right now is that somewhere around that 60-pound rate still does seem to be pretty ideal for Ouachita under our conditions. So probably our recommended rate needs to be somewhere between around 50 to maybe 80 pounds of nitrogen. What I want to say about that, though, is that this was done in Arkansas on a silty loam soil. And soil type can have an impact on this rate, and so being able to fine-tune and figure out what end of that potential range you might need to be at is where I want to kind of transition and talk a little bit about leaf tissue nutrient sampling, because leaf tissue nutrient sampling can really help you kind of fine-tune for your specific location, your soil type, your variety, and maybe the means with which you're fertilizing if you are putting out sufficient fertilizer, both from nitrogen standpoint, but also potassium and other key nutrients. So again, here's our annual crop recommendations currently for blackberries in the southeast. Nitrogen, 50 to 80 pounds annually. Nitrogen, of course, being very important for cane growth and fruit size, but of course we want to be careful about not over-applying nitrogen. You know, often we think if a little is good, a little bit more might be better. But of course, with blackberries, you can quickly grow a very large plant that then creates a lot of labor for yourself that you then have to manage to try and make sure that it's going to be easy to be harvested the next year. And so too much nitrogen can lead to excessive cane growth, longer internodes, which has been related to reduced yield, and potentially fruit disorders. So red druplet reversion has been associated with high rates of nitrogen. That 50 to 80 pound per acre rate is associated with an established planting, but in the year of planting, 25 to 50 pounds of actual nitrogen per acre would be recommended in year 1 for establishment. Recommended rates for phosphorus are 60 to 80 pounds per acre. There's no known yield response from fertilizing regularly with phosphorus, but of course we need phosphorus to be there for plant growth, and so if your leaf tissue samples are coming back low, you will want to make some broadcast applications post-plant. But of course be aware that phosphorus can be slow to move down into the soil and then be taken up by plants. So if you're coming back low on your leaf samples this year and then you make an application, it may take a year or two for that to show up in your leaf samples. And then our recommendations for potassium, 40 to 60 pounds annually. Notice that that's a pretty high rate, so 50 to 80 pounds of nitrogen, 40 to 60 of potassium. Of course, potassium is very important for fruit set, but also fruit quality and cane density. And one thing that I sometimes suspect about what we're seeing in some of our leaf samples coming across the southeast is that growers focus on nitrogen and are maybe a little lighter on potassium, and we may be getting a little bit of some imbalances going on there because if you really over-apply nitrogen, that can actually inhibit potassium uptake. So making sure to make those annual applications of potassium. Again, broadcast applications can be slow to move down into the soil. Some estimates suggest that it moves about downward 1 inch for every 2 to 3 years on fine soils. So if you're making big broadcast applications, it's going to take some time for that material to move down to where plants can take it up. But fertigation applications, we have been able to see that you can increase potassium in plant tissue relatively quickly. So let's talk about these are our recommended ranges of what we think you should be putting out, how you can then check in and see, all right, with what I'm fertilizing with, am I in the right target range? And this is sort of just, again, a tool in your toolbox to check in with the crop and hopefully identify if there's a deficiency starting to happen, to identify that before you actually see the symptomology in the leaves in the field. Because what we would never want to happen is to go out into the field and recognize that, man, everything looks a little off, because at that point, we're probably already impacting yield. We would much rather see it show up as a slight deficiency in a leaf sample where we still have time to make some adjustments before it's actually impacting yield. So soil testing we use to check in and see what nutrients are present in the soil, and primarily to check in on soil pH, because soil pH is really important for determining what is going to be available for the plants to take up. And then plant tissue nutrient testing basically tells us what the plant actually went and took out of the soil and is now utilizing and being used by the plant. Our recommendations for how to leaf tissue sample blackberries currently is for, on a floricane fruiting type, to collect 50 to 100 of the most recently mature leaves. And here in this picture on the right-hand side, you can see that arrow pointing to a most recently mature leaf. So it's a leaf that's about 4 to 5 back from the growing point on a primocane. And for those samples to be pulled in July. On primocane fruiters, similar, but pulled off of primocanes at the red to green fruit stage. Now, one of the issues that we see with this is that we're telling you to pull these leaf samples basically towards the end of the season. So you get to check in with your crop late season. So that means if you identify that you're a little bit low on a nutrient, you've kind of already missed the opportunity to really impact that year's crop. And what you would then be doing is amending your fertilizer application for the next year. So we start to get into this position where we're kind of a little bit behind if we're always sampling in late season. So we have a team that was interested in figuring out, can we do sampling earlier in the season so that we can check in early and give growers a better indication in season of if they're on target or not. These are our current recommended tissue nutrient ranges, sufficiency ranges, and this is again for those samples pulled at post-harvest. We estimate that you should have 2 to 3% nitrogen, 1.5 to 2.5% potassium. So what we wanted to do was go across the southeast and pull a lot of samples from blackberries grown in a lot of different regions and just check in and see if those sufficiency ranges are adequate. And so this was a trial that we did across a lot of colleagues for several years. And this is the results that we got for 2 of those years. And what I want to show here is just how much variability we see and how much nitrogen is in the plant at different stages of the year. So at bloom, we see that there's somewhere around 3 to 3.5% nitrogen in the plant. And this is, again, from samples pulled off of primocanes. When the primocanes are starting to merge, also early season, when they're about 6 inches tall, still in that range. As we start to set fruit, we start to see that amount of nitrogen being held in the leaves starts to go down, which probably makes sense. Some of that nitrogen is getting moved into that fruit. So around small green fruit, amount of nitrogen in the plant drops to about 3%, and then at harvest and post-harvest, we get down to closer to about 2 to 3% nitrogen. But as you remember, our sufficiency range that I showed on that previous page was 2 to 3% nitrogen, is how much should be in the plant in post-harvest, which matches up pretty closely with what we're seeing. But the risk is if you use that 2 to 3% nitrogen recommendation and you apply it to samples you pulled at bloom, you're going to think, man, I'm doing a great job of fertilizing because I'm way above 2 to 3% nitrogen. But you should be way above 2 to 3% nitrogen at that stage. And so our goal here is that we want to have better recommendations for how much nitrogen should be in the plant at all of these different stages so that you can check in season and amend those. Right now it's looking like you should be somewhere between 3 to 4% nitrogen at bloom. These are the averages of what the nutrient, average level of nitrogen, phosphorus, potassium, calcium, etc. that were in our different samples pulled at different years compared to our current established ranges. So on average, for most years, we were within the recommended range of 2 to 3% at post-harvest for nitrogen. But for phosphorus and potassium, across all 3 of the years that I'm showing here, we were below the range that we currently have published. And so we're kind of looking into this a little bit more because these ranges were, again, developed for the Pacific Northwest, and then we have adopted and amended for the Southeast. But it really looks like we probably need to lower our range slightly for those nutrients. I don't really think that we're actually that low on P and K and that we're in a deficiency situation. I think that our range is not matching with what we're actually seeing in the field. And so we are working on updating those ranges so that when you use these as a tool, you'll have a better indication of if you're actually on target or not for our region. I do want to point out that in only 1 year were we on average low in boron, only in 2023. But this is still a tool that you can use, and we are hoping to have some updated recommendations for going into this season. And hopefully those will be sent out through NARBA and other regional organizations. But generally what I always tell people is you're going to get these test results back, and then you're going to work with either your county agent or potentially a regional specialist to try and interpret, all right, my sample came back low on nitrogen. What does that mean? How do I need to proceed? One thing I always like to remind people is just because on paper it says that you're low in nitrogen, I want you to always look at what's happening in the field, particularly with nitrogen. Because with nitrogen, we can flush a lot of growth if we apply a really high rate of nitrogen. And then when we test those leaves, they're going to show up and say that there's a lower amount of nitrogen because we push all this growth and we sort of have this dilution effect of that nitrogen being spread across all of this new plant material. So always kind of field truth in the numbers that you get on these leaf samples, because if your sample comes back and it says that you're a little bit low on nitrogen, but man, you got a lot of primocane growth, I don't want you to go out there and put out more nitrogen and force even more growth that then's going to be something that you're going to have to deal with because you have excessive growth at that point. But if it looks like the plants are really not growing at the rate that you would like, and the sample comes back low as nitrogen, that's going to be a good indicator that you do need to increase your nitrogen rate. Again, phosphorus it's a good to check in with the kind of and monitor phosphorus rates from year to year, so that way if you start to see that amount is dipping, you can make an application well in advance of you showing symptoms in the field. And then potassium, of course, this is one that I think we need to keep an eye on because we're probably going to amend our current recommended range. But do be aware that if you're applying high rates of nitrogen and not making kind of similar applications in potassium, that can exacerbate a potassium deficiency. And boron, I'll just briefly mention, boron is one that we need to be very careful with because you can quickly over-apply boron and get into a toxicity situation. The best timing for applying boron is during bloom, but of course we want to be really careful because if you over-apply boron, you can really have some burn symptomologies. But boron is really important for fruit development, and so making that early application in the early season can be helpful. But again, hopefully we'll have some better recommendations for pulling samples early season, more similar to what we do with strawberries, where you could check in at bloom and see where you're at and make those early applications. I realize this was very, very quick deep dive into fertility management, but please stay tuned and feel free to reach out to me if you have questions. This is a blog that myself and my colleague Erin Cato run, and we keep updates there from all of our different research. And of course, thanks to the Southern Region Small Fruit Consortium and Arkansas Fertilizer Checkoff for helping to support this research. And I think I might have, since I'm my own moderator, let's see how well I did on time. Oh, right on time, 3 p.m., all right. So no time for questions, but I will be around for the next day. If anybody has questions, I'm happy to chat with you all. Thank you so much. All right, so our next speaker is going to be Dr. Delcides, and he's going to give us some updates on post-harvest handling of caneberries with specific focus on strategies to maximize quality and shelf life. And he's one of our great colleagues here at the University of Georgia. Thanks, Angelos.
Thank you, Amanda. Hey, everyone. This is Angelos Delcides from UGA Tifton. Happy to be here today. I'll be talking to you about caneberries. Many of the strategies are common for both raspberries and blackberries. And I'll have some work we've done with blackberries in UGA, some results to show you with work we've been doing the past years. As you all know, blackberries have been increasing both in acreage as well as in sales. I found some numbers from the past year. The sales were about $1.5 billion, and they're projected to go up to $2.4 billion by 2032. So it's a very important crop that's increasing year after year. As I mentioned, the consumption of fresh and processed berries has been increasing, and we see that increase both in dollar sales and volume. We have berries now year-round thanks to advances in post-harvest technology, as well as big berry companies that bring fruit from all over the world, drawing on different climates, and so the supply is pretty much year-round. Some of the characteristics of the berries, we need to make sure that when we harvest berries, we harvest them fully ripe for the best flavor. You don't want to expect them to ripen after harvest. This is not happening. We're talking about very perishable crops, and their shelf life is limited by the high respiration rate, softening, water loss, loss of flavor, mechanical damage, and decay incidents that occur if the ideal conditions are not maintained. They're crops high antioxidants, and people are increasingly looking for antioxidants in their diets, so that's why they're very important. Here I have a table that shows the respiration rates and ethylene production rates of a number of berries. Blackberry and raspberry has been highlighted in red, and you can tell that they have the highest number of values of respiration rates. That means that they have the shortest shelf life compared to cranberry that, as you all know, can last for weeks or months. So the higher the respiration rate that we see in these two berries, the shorter the shelf life, which is an issue as we have 7 to 10 days in ideal conditions. I will show you some preliminary work we've done with two technologies, controlled atmosphere and ozone in blackberries in Georgia. These technologies have been found useful in other crops, so we wanted to see what they can do to extend the shelf life of blackberries, and if they can do that without any adverse effects. So to do that, we used cold storage, of course, 32 to 34 Fahrenheit, high relative humidity, and we had two technologies, controlled atmosphere storage and gaseous ozone addition. We looked at the quality, deterioration after harvest, firmness loss, color reversion, diseases, as well as off-flavor development. To give you an idea, right now we're looking at 7 to 10 days of shelf life. We wanted to extend that to 14, and you're going to see the data at 2 time points. Why we did that? We'd like to give additional options to our farmers to extend the shelf life of blackberries, to fill market niches, and to ship products to more distant markets. This work was done in Georgia, and as I said, we used CA and ozone, and we're aiming to incorporate these technologies with low-cost modifications in local producers. A little bit more about the work we've done. As I mentioned, we harvested blackberries and packed them immediately in the field in clamshells, and we did 3 measurements on day 1, day 7, and day 14. We looked at visual quality, soluble solid concentration, or bricks, titratable acidity, firmness, and respiration rates. And the treatments were the ones I mentioned before. Visual quality at harvest. I forgot to mention that we used 3 major Arkansas bred varieties, Caddo, Ponca, and Osage. Here's how they looked at harvest. We did some surveying, and we found that Caddo had more uniform and larger fruit at harvest. Ponca was medium-sized, and there was more size variability, and Osage had also medium-sized fruit. Here's the data. Caddo had the largest fruit at harvest with about 22.5 millimeters diameter on average, whereas Osage and Ponca were between 9.5 and 9.6 millimeters, and they were similarly sized. We used a visual quality rating scale where 3 was the limit of marketability and 5 was a perfect, freshly harvested fruit. And we had the same individual go through the berries and give a rating to each of them, and then we got the average out of them. So after 14 days of storage in 3 different technologies, the blue is the low temperature storage, orange is controlled atmosphere, and gray is ozone. You can see that ozone in general did not improve the quality ratings in any of the tested varieties, and controlled atmosphere resulted in improved quality ratings for Osage and Ponca. So you see here the Osage and Ponca ratings for a fruit that was stored at CA were improved compared to ozone and control. Respiration, we saw an increase over time for respiration, and this could be a sign, an early sign for the onset of fungal growth, but we didn't see any fungal growth visible. Initially, the rates were pretty much the same, and they increased over time. One of our thoughts was that ozone, since it's very active, might end up shrinking the fruit because of how reactive it is. We saw that Cado fruit did shrink, actually, when treated with both CA and ozone, whereas there was no difference in fruit size for Osage and Ponca. Firmness is also probably the most important parameter for shelf life for blackberries. We saw that initially they were pretty similar. All 3 cultivars had around 120 gram force per millimeter to begin with. For the Osage stored at ozone, we had an increase in firmness, which is probably some sort of hardening, whereas Ponca values decreased significantly compared to the initial ones after 14 days of storage. Tetrable acidity, it showed a gradual decrease over time, whereas here in Ponca you have some increase in the ozone-treated fruit. The others had no difference between treatments. Soluble solid concentration, or BRICS, as we all call it, was higher to begin with Osage. There was more sugars in the Osage cultivar, followed by Ponca and Cado. And interestingly enough, there was some increase here over time, probably due to the water loss. There was more concentrated sugars in the berries. To conclude this work that is preliminary, it's only 1 year worth of data. Cado had the largest fruit size at harvest. Controlled atmosphere affected positively the visual quality of ratings of Osage and Ponca after 14 days of cold storage. Ozone, gaseous ozone, did not affect negatively the visual quality ratings of these 2 cultivars. Respiration rates of ozone-treated fruit did not increase compared to air, which is what we thought. And Osage and Ponca firmness under CA was not affected negatively. TA decreased after 14 days of storage, and soluble solids increased over time during cold storage, possibly due to dehydration. We believe that CA, or controlled atmosphere, has some potential to extend the shelf life of especially Osage and Ponca blackberries from Georgia. We didn't find any negative effect of ozone treatment that was visible to us on the fruit quality for Osage and Ponca after 14 days of storage, but would like to do more research to elucidate the antifungal activities of ozone treatments as well as CA and the potential to extend the shelf life even longer. To do that, we secured funding to perform more work. So we have a new grant from the Georgia Department of Agriculture for the years 2024 to 2027. So I'm going to switch gears and talk about suggestions on how to harvest, pack, and store caneberries, both raspberries and blackberries. Have pictures both from Georgia and some from California, where I used to work before. Here you see a typical caneberry operation. This is raspberry out in the west, where they use hoop houses to protect the fruit from rain, often sun, as well as birds and dust. And you see how the harvest is always done by hand. Out there, they were using this system, which is not my favorite because it has extra handling steps that are damaging the quality of the fruit. In this situation, the picker is picking individual berries and placing them in these containers, and then in the end, they are moving on and dumping them into the clamshells. The timing of the harvest is usually done in the early morning, if possible, when the temperatures are lower, and we want to avoid harvesting after rain or after heavy dew. This is a caneberry operation that has no hoop houses, where you have these mobile platforms that are moving across the lines. The pickers are moving up and down the line and bringing the berries to the closest location where the mobile unit is sitting, and then here's where the quality control and packing is happening. And I'll show you some pictures. Here's how it was done. They were bringing those containers, and then someone was manually adding the berries into the clamshell. While it's probably more efficient and faster, you have multiple people touching the berry, and given how sensitive they are, this is something that was not my favorite, but it's been done a lot even today. They had shaded area for the packing area, which is something we suggest, especially in Georgia and in the South, where the heat is really high and the rains are very common in the harvesting season. Here's some more pictures of how they're doing the palletization in the field for all berries to reduce the time the pallets are loose. There's a quality assurance that's happening on the farm. There's a specific person that monitors the quality of the packed berries. They check firmness, ripeness, decay, and defects. And if needed, they retrain their harvesting crew and often give incentives for better performance. Traceability is very important, and it's common in all bigger operations. There is multiple ways of doing that, and they do it both for traceability, as I mentioned, but also to monitor how many pounds of berries or how many clamshells of berries each worker is harvesting. So they have this magnetic little button thing that each picker is carrying, and they scan it every time they deliver a set of berries. And this way, if somebody gets sick from the berries that this person harvested, they can trace it back to the individual picker. As I mentioned, rain and high heat are an issue for our region, so a covered receiving area is very important. In general, you want to avoid the high temperatures as much as possible. Quality control for all berries is also done in the cooling facility. This is a picture from Driscoll's, and they do that for both strawberries, but also for the other types of berries they produce. They take samples, weigh, measure color and firmness, as well as sugars, bricks, soluble solids for the berries that are brought in from different farms. Some guidelines, suggestions for caneberry operations. You want to pick in the morning when the temperatures are lower and the berries are firmer. You want to avoid picking when raining, immediately after rain, or when there's a lot of humidity or dew on the berries. In general, you want to pick and handle the fruit as carefully as possible. These are very, very sensitive crops, and you don't want to handle them. You want to avoid extra handling steps. Ideally, the harvested fruit should be placed immediately into the picking container and into the clamshell if possible. There should be a separate container for cold fruit that could be either used for frozen or in processing. The container should be not very deep, no more than 2 to 3 berries deep to avoid bruising during storage, and half-pint containers are recommended. Cooling is very, very important. You want to cool your fruit as soon as possible after harvest. And the temperature, the target temperature should be 33 to 35 degrees Fahrenheit with high relative humidity to avoid dehydration of the fruit. Room cooling or ideally forced air cooling should be used, and you want approximately 6 to 8 trained pickers per acre to have an efficient operation, and you want them to be well trained in order to avoid bringing immature, over mature fruit in. Picking stands are also good to place containers on to avoid them getting in contact with the ground. Some picking containers and packaging suggestions. Pulp baskets were used a lot in the past. They have been declining lately. They're inexpensive. They have a little bit of ventilation to allow for cooling. They can absorb water and juices that leak. However, these can harbor pathogens and can lead to fungal growth. Polypropylene baskets are very light. They're very cheap. They have no lid, which could be good and bad depending on if you want to have your product visible out there or if you want it protected, but also have sharp edges sometimes, and they cause injury to the very delicate berries. Clamshells are the rule of thumb, especially for bigger operations. They're strong. They're made out of plastic. They have vents, and they have hinged lids that allow boxes to be stacked without crushing the fruit. Usually for blackberries and raspberries, an absorbent pad should be placed in the bottom to absorb juices and moisture from the fruit and avoid juices leaking through different clamshells. Recommended storage conditions, 32 degrees, ideally to 34 or 35 is what I've been seeing for blackberries and raspberries. High relative humidity, about 90 to 95% is ideal. Ethylene production should not be an issue, and you don't want external ethylene in the cold room because it can create fungal growth, but it doesn't change, it doesn't improve the quality of blackberries or raspberries. CA, as I mentioned, can be used to reduce the growth of decay. It will reduce respiration and softening rates for caneberries, and there are some whole pallet covers to contain modified atmosphere that I will show you in a little bit. But in general, prompt cooling is the #1 way of extending the shelf life, and you want to do it before looking at any other atmosphere modification strategy. Forced air cooling is the best, the most efficient way of removing field heat from harvested berries. 32 is the target temperature, and it will reduce water loss, decay, and respiration rates, and will eventually extend the shelf life. The shelf life we're looking at is about a week to 10 days. We can go up to 14 days thanks to newer varieties, but more work should be done to extend possibly the shelf life a little longer. Decay is an issue, especially for blackberries. Temperature management is the easiest way of suppressing decay for caneberries. CA or MA with high CO2 can also help. Biological control and irradiation have been used, but mainly for experimental purposes. Ozone, as I mentioned, can be used, and sulfur dioxide fumigation can be used as well. Here are pictures of what I was talking about with the pallet shrouds that can be placed on top of pallets. You have this plastic that is draped over the pallet. It's sealed on the bottom, and then CO2 is flushed in, and then the pallets are shipped, usually cross-country. And back in the day, it was $10 to $15 per pallet to place this plastic shroud. The results are there is some benefit to it, and farmers do it as an added insurance step to avoid issues after the fact. Some disorders you're looking at when you're storing berries. Shriveling and water loss is the biggest one. Berries are very susceptible to water loss, and that results in shriveling and loss of the glossiness. That's why I mentioned 90 to 95% relative humidity is the best to minimize water loss. Berries do leak, especially if they're handled a lot, and that's an issue. And when you use controlled atmosphere, you can cause off flavors, discoloration, and depending on the temperature, on the duration of exposure, and whatnot. With that, I'd like to give you these resources if you guys are growing, harvesting, or packing caneberries. We put together this publication last year with Dr. Rubio at UGA, where it has some general guidelines on how to harvest and handle blackberries. They're available. It's available on the extension UGA website. It's circular 1282. You can look it up by this number. There's also an older NC State extension publication, the AG 697, as well as the UC Davis produce fact sheet that you can look up for both blackberry and raspberry. With that, I'd like to thank you for your attention. Oops. I'd like to thank Ramsey Korn and Noah Rodriguez, two students who did a lot of work. I'd like to thank NARBA and the Southern Region Small Fruit Consortium for funding some of this work, and of course, Polk Vineyards and the Polk family for their great support throughout the years with blackberries that they grow in South Georgia. With that, if I have any time, I'll be happy to take any questions. Hey, Gary.
I like your car where you're blending hot air and cold air, making, like 62 degrees. Is there any thought to that maybe you shouldn't be cooling with 32 degrees? There's no way to modify it, say 40, carry the fruit to 40, then go to the second step.
That's a good question. Yeah, I've heard before that cooling down too quickly could induce color reversion. I haven't looked into it. But I've read of somebody doing like steps cooling down to, let's say, from 80 to 65 and then going down, but I haven't seen the results. This is something we might be able to do this year if we have time, to look at the different temperature steps and if we could, improve the red droplet reversion issue. But yeah, that's something that I haven't looked into it, and I don't have data to support it or discredit it. So that's a good point, though. Any other questions? No questions? Thank you so much. Thank you.
So our last presentation today is our grower profile, and I always appreciate any grower that's willing to participate in this, because I know it's a big ask to stand up in front of your peers and share a little bit about your farm, but very grateful to the Rhodes family for being willing to be our grower profile this year, and very excited to hear a little bit more about your operation and what you got going on in North Carolina. So thank you, Dalton and Austin, for joining us today.
Good afternoon, guys. I'm Dalton, and this is my brother Austin. And Dad couldn't be with us. He stayed back just in case the snowstorm actually hits. But we started, we've got a family farm that's been in our family since probably the mid-1800s. Not exactly sure when, but it's always been cattle and apples there. And that was a really good business, and Papa Dalton was big in it. He made a couple apple varieties, started the Apple Festival. But then in the 80s, there was a big market downturn, and basically that market went to crap pretty fast. So it ended up being just cows by the time we came around. And that's Austin's favorite cow. Her name's Maybelle. She's a doll. So the weather where we are, we're at about 2,300 feet in elevation, and we rarely get above 90 in the summer and rarely below 0 in the winter. So it should be a perfect berry growing environment, and people are real interested in coming there to grow berries. But we also have 62 inches of rain a year, so that makes stuff real complicated sometimes. So the way we got started was Dad made me get an internship in college, but it couldn't be at any farmer that I knew, so I had to start looking. And it just happened to be that Driscoll's was hiring for a production intern in Hendersonville. And I know I saw, is Ricky Holness in here? Yeah, Ricky was my boss back then, taught me a lot of stuff about blackberries. So I thought we knew a whole lot, and it was going to be easy doing that. But then after they pulled out, we grew 1 acre, and we learned how to lose a whole bunch of money that year. So, you know, we did what farmers do, and we planted 12 more acres the next year. And whenever we did that, we didn't go with the high tunnels and everything. We went like with what the other farmers around were growing their stuff like. And it would have been great if we hadn't had the labor issues that started coming in after that. And then we had to change the plan again, so we're always evolving. But when we first got started, if it hadn't been for the Farm Service Agency pretty much loaning us the entire farm because we had no money to start with, and NC State Extension and Karen, I don't know if she's still in here, but she's probably the best extension agent in the whole country, and she helped us a whole lot. The North Carolina Department of Agriculture has helped us on marketing and selling and tissue sampling and all that kind of stuff. Brent Brown and Cal Lewis are two pretty good mentors to learn how to grow berries from and go see their farm and see what you're doing wrong and how to fix it. And of course Ricky again. And we work pretty close with Helen Agribusiness and doing leaf tissue sampling, like what Amanda's talk was about earlier. We've been working with them for the past 4 or 5 years. And our production's really picked up once we got that fertility dialed in. So when we first started, we thought we're going to grow 100% good berries that can ship all over the country, and that was a big mistake. So we had to switch our marketing to fit kind of the berries we can grow. So we can grow about 35% really high grade, 35% A grade, 15% just all right berries, and then 15% crap. So we finally figured out how to sell those. But the 35% that we sell like on the national shipping market, it's got to be really good quality to be able to hold up to shipping long distances. Otherwise you get rejected a lot and then you lose money. The price fluctuates really big on that though, and it seems like the lower the price is, the harder the grading is. So we had to figure out how to get away from that market for part of our crop. Because we have a lot of days that look just like this picking, and as y'all know, that's not the best kind of weather to try to ship across the country in. So we use this mainly for our peak production in July and August when it's drier. And then because of COVID, we ended up getting into we have our own private label called Carolina Mountain Berries, but we pretty much ship from June 15th to September 30th with that, and we go to local grocery stores. And this is a picture of Austin on the first berries that we picked that actually got in there. And we thought that was going to be easy too until we ended up having to make sure all our orders were filled whenever it rained for a week. So we had to make a lot of grower relationships, pick up berries, make sure you fill that in. It's rewarding, but it's really high pressure trying to keep those customers happy. We can use slightly riper berries for that since our travel distance is under an hour from where we are. And that's been pretty good. It's kept us afloat even when the national market's pretty bad. Then we sell about 15% of ours as local gallons too, and we just slowly accumulated customers over the year. We still haven't figured out how to train them to tell us like 3 days in advance. They usually just call when they're 15 minutes away and say, hey, I need this. So we're trying to get that figured out. But it helps us a lot on like cash flow at the beginning of the year, because that's cash right then instead of having to wait 30 days. So that helps us. And you can use your berries that aren't suitable for clamshells, but they're a lot better than juice berries, and get a pretty good price for them. And we do that about June through September, but the demand's higher in the summer months when kids are out of school. And then we sell the bottom 15% that aren't worth anything for juice berries, and sometimes if you're good at marketing, you can figure out how to sell that for more than what your good berries are for. It helps us keep the field clean without losing money on it, and gives us other options if the markets aren't going well. And it's a year-round income source for us. And I'm going to let Austin talk about our variety mix that we have.
So floricanes, that's kind of the majority of what we had when we started. It's really what we started with. We have an acre and a half of Ouachita, an acre and a half Osage, and 9 acres of Navajo that we planted when we first got going in 2015. And it performed pretty well for us. There was a lot of management we had to learn. So primocanes, we like them now. But also the timing of floricanes, where we're at, we've never really picked a primary bud fully because we always wind up getting late frosts. And so that's another thing with floricanes we had to learn. We ripped 4.5 acres of Navajo out, and we put 3 acres of Ponca in 2020. And like I said earlier, lots of issues with spring freezes, so that's just another hurdle we have to go through with that. But Ouachita, that's a hard-hitting, beautiful crop. It's really my favorite for picking. I enjoy the quality. There's not really any issues with bruising on it. You can pick it kind of halfway damp, and it'll still ship perfectly fine. The berries are uniform. They're large. They're routinely the size of your thumb. They are sensitive to spring freeze, and they do have white druplet problems, but it kind of just depends on the weather. If it's really sunny, you just got to watch for it. They come in about the end of June, and they go through the end of July. And Osage kind of fills that. They're also in that same period. They produce over a long time, though, and they taste pretty great. That's actually my favorite tasting variety we have. They're just not very uniform in the way they're shaped, so you can get a lot of small ones that just don't look perfectly conical. And they go from the middle of June through the end of July. Ponca, like what Amanda was talking about with putting out nitrogen whenever you plant, we put out 100 pounds to the acre, 400 pounds to the acre. It was a lot. It looked like we grew pine trees instead of blackberries the first year, so we learned that pretty quick. But it's been a learning curve ever since we've had those things.
Just because they say it's a dwarf berry doesn't mean you need to fertilize it more.
Yeah, we grew trees. But they do have a good flavor. They're large, and we've dealt with pretty much every disease and insect known to man on them. Click beetles, Japanese beetles, purple blotch, everything like that. And they have a high secondary crop potential after a spring freeze. The issue with Ponca that I've found is they're not necessarily the best for shipping. The conditions have to be just right for us to be confident to ship them. But we're getting better at it every year with those. They go from the middle of June through the end of July, and the funny thing about them is they're the last variety we have that blooms as a floricane, but it's pretty much the first one we pick, so they have a very short bloom period. Then we have Vaughn. They're similar to the Ouachita, but they're in the Navajo window. They taste good. They size up pretty well. And the cool thing about them is whenever we pick them, they all come on at just one time, so it's a very heavy and intense harvest window, but whenever you're in there and you're done, the pickers are happy and you're happy too. But we go from July through the whole month of July on those things. Navajos, we've got a pile of those, and if you guys can grow weeds in your lawn, you can grow Navajo blackberries. They're really easy to grow. They're good, but on a cloudy day they can be sour. They consistently harvest pretty heavily, and the fruit's not large, but it's not really, really small. And the quality's good, but they can get leaky after days of rain. And they go from July through the middle of August. Our primocanes, we have 8 acres of Traveler that we put in 2017. And we've had numerous issues with those. The first 4 years we had them, we didn't know if they even were going to produce fruit or not, but we figured it out. We found broad mites, and $50 worth of ivermectin per acre will fix them, so that's great. Ricky Holness, he advised us on how to prune them. We learned that if you prune them about knee-high before they go into the winter, that allows them to overwinter better, and you can just prune them off shorter after it starts to warm up in the spring. That just kind of prevents overwinter damage. And Wayne Mitchum said we should do away with the plastic, kind of open up that floor and just allow it to breathe. And that's worked out pretty well for us. So there's Traveler. Like I talked about, best tasting berry we grow. The fruit is large. They can get bruised by the wind and the rain. And the reason these things are more susceptible to getting bruised is because the way we've learned to train them the best is just kind of let them do their own thing inside the trellis. So we've tried thinning them, we've tried tying them over to both sides of the trellising, we've tried looping them over and tying them, and everything we did and just added labor to, it impacted your yield in negative ways. So we just found out the easiest way to grow them and the best way to grow them is just let them do their own thing. So they're not very labor intensive, but they also don't yield too terribly much. And they carry us from August all the way through the end of our harvest, which is around the first frost. But September 30th is whenever they stop being really marketable. So raspberries, we've trialed off and on since the beginning. And really through it all from the very start, we've probably had about 20 varieties of raspberries on the farm, but only one variety stood out. And it's called Crimson Treasure. And we planted 10 acres of that in 2023. It came from Cornell University, and the quality on it's just fantastic. We love it. So we planted a high-density trial in 2024, and we also planted a fumigated trial in 2024 as well. And that got impacted by Helene, so we'll be able to put it back exactly how we want to this coming spring. So it'll be good. But the Crimson Treasure, it's a dry berry that holds up well in our environment. They're large, attractive, and uniform. They're susceptible to purple blotch and spur blight, but if we spray and stay on top of them, the fruit quality is great. It's excellent. The pickers love it, and they actually like picking raspberries better than they like picking blackberries on our farm. Yeah. Anybody can pick a raspberry like these. They don't leak. You can fold them in half both ways and flatten them and put them in a clamshell and leave them in the cooler for 2 weeks and nobody would know the difference. They're just wonderful. But they have an upright, compact growth pattern. And the fall crop is from the middle of July through that first frost, late September, early October. And the spring crop is from the 1st of June through the middle of July. And the spring crop is obviously heavier on these things, and you do have better quality fruit then too. Crimson Giant, that's another variety that's turned out pretty well for us. They're just like the Treasure as far as quality and yield, but the size of the fruit's much larger. They're taller and floppier plants too, though. But they go from that same middle of August through first frost window. Double Gold, this is not necessarily a shippable variety, but it's a fun one because whenever we have them, everybody's trying to beat the doors down to buy them to take to farmers markets. They're a very picky plant. You could kill them by looking at them wrong, but they do produce a pretty piece of fruit. They taste pretty good. It's got a slight peach flavor to them. And they're good for farmers market boxes. They're good for selling for juice. And you can also spring crop and fall crop them like the others. Niwot, it's a black raspberry. And around our farm, we noticed whenever we were growing blackberries at the very beginning that the black raspberries grew wild along the fence lines. And they were the healthiest looking caneberry on the entire farm. So we decided, you know what, maybe our climate here is conducive for growing black raspberries. So we tried them, and they're the healthiest looking plants. You don't have to do much to them at all. But the berries are small, and the harvest is very concentrated, but you do get to hit that niche market, and people like them. They're good for processing. It takes a lot of them to fill a gallon box, but for processing, people love them. And they go from the middle of June through July 4th. And fall crop, we're not necessarily sure what they'll do, so we didn't try that this year.
So some of the lessons that we've learned is it's real important to diversify your market because you never know what's going to happen. You need to have options for where to go with your fruit instead of trying to shove a square peg into a round hole. And networking and visiting other farms and just having a bank of people that you can call on for when you got a question and what am I doing wrong here and hey, how can I do this better? Always be looking for ways to save on labor because I don't think that's getting any cheaper, and we're going to have to figure that out or else none of us are going to be farming blackberries anymore. And when we first got started, I just wanted to set yield records or something because I was really wanting to chase that top end yield, but we slowly found out that profitability is more important than yield. You need to make sure you can lock in pricing for part of your crop if you can, so that you're kind of protected for those years you have a down market. And be willing to say no. Like that's where this juice berry and different marketing scheme comes in for us. Because I mean, if it's a $12 market, Like, if I didn't have all that stuff, I'd have to say yes, and okay, here it is, I just lost money on that flight I gave you. But if we have other ones, then we'd be like, no, we can't do that till the pricing's better, and you don't lose money that way. So the goals we have going forward is we want to add a lot more mechanization in there to cut down our labor costs. And like this picture right here is part of our high density raspberry and blackberry trial that Josh Mays is going to talk about more tomorrow. But we're looking at a way that basically we can do all of our pruning from a tractor and cut down those off-season costs and make the picking more productive, cutting down your cost per box to pick. And that's where we're looking for the best system for increasing picker efficiency. We're always looking for better varieties. And if we can ever figure out blackberries and raspberries, we might try to add strawberries because, you know, we're always looking to do stuff. And growing those value-added sales like the jam and jelly and pie filling, and figuring out a way to minimize our frost risk. That can either be through advancing the timing of primocane crops to where we don't need a floricane, or investing in a wind machine or overhead irrigation, just whatever ends up making the most sense for us. And so that's Dad in the middle who couldn't make it. But does anybody have any questions?